Because you were doing 2 today.
Yeah. But they work really nicely together. So in this first exercise, we're doing the differentiation of exponential functions. So derivative of e to the x is e to the x. That's our first one. And in the second exercise, it's going to be kind of applications of it. So it's still using the same rules. Okay, so this first one that I've highlighted is what we discovered yesterday. If I differentiate e to the x, I get e to the x. So it should be the easiest thing in the world to differentiate because it stays exactly the same. However, if I change the exponent so that it's not just an x, okay, it does get a little bit more complicated than that. If I have a power like ax plus b, okay, then whatever is in front of that x, which is the a, that is going to come down the front. Okay, so the a comes down the front, but the e to the whatever the power is, the power stays the same. Don't try to subtract 1 like we did for the other technique. The power still stays the same. And this bottom one here is a generalization of that rule. It is saying whatever the function is for the power, you differentiate that function to bring it down the front, and it's e to the same function in your answer. Okay, so this first exercise is just using those rules to practice differentiating a few things. So just 4 little questions. 1a. Find the derivative of y equals e to the power of 3x plus 2. Okay, so we have a power that's not just an x. So we take the derivative of the power, which is
log e y.
No, derivative. Derivative is 3. So don't forget your notation. Differentiating means that it's y dash, or you could use dy over dx if you prefer. The 3 comes down the front, and the exponential with the same power. And that's it. I've differentiated. Okay, part B. Let's do it again. Y equals 5e to the power of negative 4x. Differentiate the power. What's the derivative of minus 4x?
20.
Negative 4. I'm just up to the negative 4 for now. And you want to times that negative 4 to the number down the front. So you do negative 4 times 5, and that's how some people were getting negative 20. E and leave the power the same, negative 4x. Does that make sense? Good. Part C. Y equals e to the power of 5 bracket 2x minus 7. We do know how to differentiate brackets, but since there's no power or anything on that bracket, it's going to be easiest if we expand that first before we differentiate it. So expanding, just the bracket. So 5 times 2x is 10x, and 5 times minus 7 is minus 35. Now I haven't differentiated yet, so that's why I've just used an equal sign. On the next line, when I differentiate, I'm now going to call that y dash equals. So the derivative of the power is 10, so that will come down the front, and then the rest of the exponential stays exactly the same as it was. So e to the power of 10x minus 35. Part D, x e to the x. Looks innocent enough. But who can tell me the problem with this question? Or the catch I should say, with this question.
It stays the same.
Nope. No one knows? If you have got an x term multiplied by another x term, you must use a product rule. Must use a product rule. So we have a formula for that, which was our VOOV. Remember VOOV? So we need to have a u and a v. So I always make u the first x expression, the first term, which is x. Everything okay?
I was just saying Isaac he can come do leadership because he forgot to fill in the form, so he thought he wasn't allowed.
You're leaving us. Okay. Good luck. Don't forget to catch up.
Oh, no.
All right, v is the second x expression, which is the e to the x. And we know we need to differentiate both of those things. So u dash is equal to 1, and v dash, derivative of e to the x is e to the x. Good, doesn't change. Okay, so a little recap. The product rule, or VUV, is v u dash plus u v dash. That's the formula. There is a slightly longer version of that on the formula sheet. So instead of saying u dash, it says du over dx. And for v dash, it says dv over dx. But it is on your formula sheet. Okay? All right, and we just want to sub in what we've found. So v times u dash, that's those two there multiplied together. So 1 times e to the x is going to be e to the x. Then we have a plus, and we want to do u times v dash, which is x times e to the x. So that's x e to the x. Now I'm happy for you to leave your solution like that, but you'll often find that the textbook will factorize out any common factor. So there is a common factor of e to the x in there. So e to the x bracket. That means I've taken the whole first term out at the front, which means there'd be a 1 left in the bracket from the first term. And for the second term, if I've taken out the e to the x, there would be a plus x for the second term. Okay, so that is it for 11C, just making sure that you can practice all those differentiation techniques.